All right, this video is on Chapter 6, Section C, on how to diagram using Venn diagrams, categorical syllogisms in the modern interpretation. So when you're diagramming a single categorical proposition, all you need is two circles. One circle represents the subject term, and the other circle represents the predicate term. And so it looks like what you got up here. It's an immediate argument. You've got these four different sections. Here's the S, here's the P, and you got 1, 2, 3, 4. When you are diagramming a syllogism, you add in a third circle that represents the third term. And the result is a diagram like this with 8 different sections where these circles overlap. And that means you've got 3 different pairs of circles. And each of those pairs of circles represents one of the statements in the syllogism. Or actually, it represents the premises. And if it's a valid syllogism, then the conclusion will also be contained. So we always set these up in the same way. You've got this triangle of circles. On the bottom left is the subject, which is going to be like where the minor term is. On the bottom right, you've got where the P, where the major term is, and then up top is going to be the middle term. And we number the sections like this. Now, let's turn to how we diagram universal propositions. When you diagram universal propositions, you're going to use shading, and you're going to shade out the areas where nothing is. And for each of these statements, you're going to shade 2 sectors of the Venn diagram. So if we have an A-type statement, you're going to be shading a section that looks like this. If you have all P or M, then what you're going to shade, what you're saying is all the P's are in areas 6 and 7, because that's the area that overlaps with M. That means you're going to shade out areas 2 and 3, because those are the parts of P that are not M. And so you want to say nothing's there, and you shade those out. If you have an E-type proposition, it's going to say no S or M. Well, you look at the overlap area between the S circle and the M circle. And there's 2 sections, 5 and 6, where they overlap. And you want to shade out 5 and 6, because that says there's nothing there in that common ground between S and M. None of the S's are M. There is no common ground. So any A-type proposition, you're going to get like the big 2 shade area. It's going to be either 2 and 3 or 8 and 7 or 8 and 5. It's going to be around the edges like this. The E-type propositions, it's one of the areas you shade is always going to be area 6, that central one. And then you're going to either shade area 5 or 7 or 2. It's always going to look like this sliver here in the middle of the diagram. So those are our universal propositions. Particular propositions are going to use X's. So the complication is that when you have an I-type proposition or an E-type proposition, they're now going to affect 2 different areas. Okay, so let's say we've got an I-type proposition which says, you know, some P are M. Okay, what that is saying is that there's at least one item in the overlap area between P and M. And the overlap areas between P and M are 6 and 7. And so what we're saying is there is something, and it's either in 6 or it's in 7 or in both. But we don't know which. So that means you have to put the X on the borderline between those 2 sections, 6 and 7. And what that's saying is, look, the something that this statement is talking about could be in either one or both of these areas. Either one or both. We don't know whether the some P that are M, we don't know whether they are S, because if they're also S, that means they're in the 6 area, or whether they're not S. And if they're not S, they're in the 7 area. or whether there's some of both. Then when you get to the O-type proposition, so to go back to the I-type ones for a second, the I-type propositions, you're going to have an X, and it's going to go on the line. It's going to go on one of the borders of the 6 area, one of the borders of that central overlap area. When you get to the O-type proposition, they're always going to be on either one of the, they're not going to be on the edge of the 6. In other words, they're either going to be on the edge of the 5, one of these two sides of it, or of the 7, or of the 2 areas. The O-type proposition is saying, let's say we've got some S are not M. So here's the S circle, and we want to say some of the S's are in the area that's not 5 and 6. In other words, what area of S is left? Well, you got 1 and 2. But we don't know whether the some S's that we're talking about are in area 1, if they're not P, or whether in area 2, they are P, or whether there's some of both. So we have to put the X on the edge between 1 and 2. And so that's how you're always going to do the O-type propositions. They're going to be on one of those edges, edge of 2, or 7, or 5, but they're not going to be in the edge of the 6. Okay. So far, so good. I know some of you might be freaking out at this point. I have a whole nother video walking through examples of these, so you can watch that as well. Things get really interesting when you are diagramming the premises, 2 premises, not just one, on one of these Venn diagrams for syllogisms. So here's how we do it. Let's say we've got this argument. What we want to do is we want to diagram both of the premises, all right? So the first one says some designer drugs are addictive chemical substances. So D is going to be designer drugs, A is going to be addictive chemical substances, I is going to be illegal drugs, okay? So the first premise is saying this, some D are A. So here's our D circle. Here's our A circle. The overlap between them is areas 6 and 7. And what we're trying to say is something is here in this overlap area. We don't know whether it's in area 6 or whether it's in area 7. So we're going to put it on the edge between the 6 and 7. Remember I told you that I-type statements like this are always going to be on one of the 3 borders of the 6 area. And now we want to diagram the minor premise. Some illegal drugs are not designer drugs. Some I are not D. Now this is an O-type proposition, so it's going to be on one of the borders of 5, 2, or 7. I'm not touching the 6. But some I, so here's I, and we want to say they're not D, so they're not in the 5 and 6 area, so they're either in the 1 or 2 area. So the I's that are not D. And so we want to put the X on the border between the 1 and the 2. So that's why we put the X right there. Now at this point, we have diagrammed both the premises. Now we can use this diagram, we can look at it and interpret what we've got here to figure out whether the syllogism is valid. Now here's how you do it. You look at the syllogism, you look at the conclusion, and after you diagram the premises, if it is valid, then the conclusion will already be precisely diagrammed. If it's not valid. So what does our conclusion tell us? Some illegal drugs are not addictive chemical substances. Some I are not A. Now, if we were to diagram that conclusion, some I are not A, then we would have to have an X, here's the I circle, and the not A part is area 1 and area 2, area 5. If this was a valid argument, then there would be an X already in area 1 or in area 5 or on the border between 1 and 5. But there's not. So therefore, it's not valid. Because the premises don't necessitate that conclusion. They haven't already baked in the truth of the conclusion. Now, if you're observant here, you might be wondering something. You might be saying, hey, Sasser, wait a second. there is this X on the border of 1 and 2, right? And that means there could be something in 1 and there could be something in 2. Well, if that X is in the 1 area, well, then that would be an I that is not an A, an illegal drug that's not an addictive chemical substance. So why is this not valid? Doesn't that count as a diagram of the conclusion? The answer is no. Here's why. Because the X is on the border between 1 and 2, that means it might be in area 1, but it might not. It might just be in 2. And so it's quite possible that that conclusion is false, given all that we've already said in the premises. And remember, for a valid argument, a valid deductive argument, the premises necessitate the conclusion. They don't just leave it open as a possibility. They make it necessarily true. This doesn't, because the X could be all the way in the 2 area. That's how you're going to use Venn diagrams to determine validity. You're going to diagram both of the premises, and then you're going to look at that conclusion and say, is the conclusion already diagrammed or not? Do these premises already necessitate the truth of the conclusion? Let's try another one here. And this time, will make things really special, because we're going to combine a universal premise and a particular premise. And that raises its own twist, which might make your head spin for a second. It's very doable. It's just when you first see it, it takes a little bit to get used to. Okay, so our major premise here is particular. Some birthday gifts are expensive presents. It's an I-type statement. So some B's are E's. Now, that means we want to use an X, and we want to put it in the area where the B's, the birthday presents, and the E's, the expensive gifts, overlap. They overlap in areas 6 and 7. Now, typically, we would put the X on the line between 6 and 7, because that minor premise by itself doesn't tell us whether the items we're talking about are in one side or the other. So in your mind for a second, keep this X on the 6 and 7 border. Now we're going to go on to do the universal premise. All expensive presents are luxury items. All the E's are L's. Okay, so here's the E's, and we want to say all of them are in the area of overlap with L. All of them are in 5 and 6, which means nothing is in 8 and 7. We want to shade out 8 and 7. Now, if in your mind you had the X on the border between 6 and 7, at this point, after you shade area 7 out, it's like you would bump that X all the way over to area 6. Here's why. At first, we left it open. We said, hey, look, the birthday presents, the stuff from the minor particular premise, the major particular premise, could be in either one of these areas. But then once that minor premise tells us, no, there's nothing in 7 shaded out, the shade bumps the X over into the open area 6. We know that those birthday presents have to be in the 6 area. They can't be in the 7 area. So that's how we end up with this diagram. Now, at this point, in fact, when you have a syllogism that has a particular premise and a universal premise, you can actually make your life easier by diagramming the universal premise first. Imagine if we diagrammed the minor premise first. And first, we shaded 8 and 7. And then we'd gone to the particular premise and said, well, some of the birthday presents are expensive presents. We would have gone to B and be like, okay, what's left in the overlap area between B and E? Oh, it's only area 6. That's the only place we could put the X. So instead of like provisionally putting the X on the line and then bumping it over when you shade the adjacent area, you just put it directly in the only remaining area in the first place. So it can make your life easier if you do the universal premise before you do the particular premise. All right, at this point, we've diagrammed both the premises, and we want to ask ourselves, is this a valid argument? So we want to look at the conclusion and ask, has it basically already been baked into the diagram of the premises. Some luxury items are birthday gifts. The diagram that if there would have to be an X in the area of overlap between the L's and the B's. Some of the L's or B's is what it says. Is that already true? Are some of the L's B's? Well, the LB overlap area is 6 and 2. Is there an X in the 6 and 2 area or on the line between them? Yes, there is. There's an X in the 6 area. So that means if those premises are true, the conclusion has to be true. It's baked in already. It's already in the diagram. So you know that the syllogism is valid. That's how you use the Venn diagrams to determine validity. So you could look at another example here, and this one has all universal statements in it. All P are M, all S are M, therefore all S are P. Let's look at the diagram here. I'm going to go ahead and just pull it up. All P are M. That means there's nothing in the area of P that is outside the M overlap area. So we shade out this area and this area for the major premise. All the S's are M's. All the S's are in the area of overlap here with M, so you shade out this area of S and this area of S, which was already shaded out. Now, look at all S are P. Now, if that was true, here's what we'd have to see diagrammed. There would be no S areas left white that were outside of the P area. We would have to have shaded out not only this part of S, but also this part of S, because all the S's are P, and this area, these S's are not P. So this is not valid because the premises didn't necessitate the truth of the conclusion. It could still be false. So that's how you use these Venn diagrams. I've done a lot more examples in another video, but so I'll leave you to that.